Hi, welcome to Miss Monts TV. Today we're going to study about addition of vectors.
Vector with both direction and magnitude.
So, a vector quantity has both magnitude and direction. And we first represent vector quantity, that is, using an arrow. So the tail of the arrow is the origin of the vector. The length of the arrow represents the magnitude or how big is the quantity. The head of the arrow and the direction of the arrow indicates the direction of the vector. So, combining vectors are called resultants. So, this is the combined effect of vector quantities. In this video, we will use the following steps. Number 1, we will resolve vectors into its x and y components. 2, we'll get the summation of the x component and the sum of the y component. And if there's an angle involved, we will use basic trigonometry. So, first we have to know how should we resolve a vector into its components. So each vector has two components, x and y component. So we need a Cartesian plane. So, example, 5 kilometers north. So we will first draw the Cartesian plane. So in this video, I usually put a scale of 1 centimeter is equal to whatever the vector is, 1. So 5 kilometers north, meaning from the origin, we will draw the 5 kilometers north. Then we will get the x and the y component. As you can see, it's going to the north. So there is a 0 x component. And the y component is 5 kilometers, and it is positive because it is upward. An example. Another example is 8 Newton south. So we will draw the Cartesian plane and we will draw the arrow of 8 Newton south. So from the origin, we will draw it going to the south 8 centimeters. So what is the x component? There is no x component because it is going downwards. And the y component is negative 8 because it is downward in the Cartesian plane. So that's negative 8. 4 meter per second east. So again, we will draw our Cartesian plane with a scale of 1 centimeter equals to 1 meter per second. And we will draw our arrow 4 meter per second. So, do we have an x component? So we have an x component that is 4. And it is positive because it's going to the east. And the y component is 0 because there is no y component. Next example, 6 meters west. Again, the Cartesian plane. And it's going to the west. So our x and y component, we have negative 6 because it is 6 going to the left, to the negative side of our Cartesian plane, and y is 0. How about 7 kilometers, 60 degrees north of east? So we'll draw our Cartesian plane. Remember, if it is north of east, if you're drawing using a protractor, you will start from east. Read it as 60 degrees and then write your line 7 kilometers. Then, this is our vector and we have to make it a right triangle. There, and we'll copy it. From this right triangle, we will identify the parts. That is 7 kilometer and 60 degrees. Now, let's identify the parts of the right triangle. The longest side will be the hypotenuse. The one opposite of the angle, if this is the angle, this side is the opposite. Okay? And then, if this is the angle, the one beside it, beside the angle, is called the adjacent. Okay? So our opposite is the vertical line, so that will be the y-axis. And adjacent is the horizontal line, so that will be our adjacent. So now let's get the x and the y components of this vector. We will use SOHCAHTOA. This basic trigonometry concept, you will see this in another video, because I made another video for the mathematical concepts that you use in studying physics. So this is SOHCAHTOA, sine, opposite over hypotenuse. That's sine, opposite over hypotenuse. And then cosine, that is adjacent over hypotenuse. And tangent is opposite over adjacent. So you can start with x or y. So let's start with y. So y is the opposite. Sine, opposite, which is y, over the hypotenuse 7. So y equals 7 sine 60. Positive, because it is going to the north. Then cosine, x over 7. That is cosine adjacent over hypotenuse. So x equals 7 cosine 60. And that is positive because it is going to the east. Another example. 10 kilometer, 50 degrees east of south. So let's draw the Cartesian plane. 50 degrees east of south, meaning the angle will be coming from the south going to the east. 50 degrees. Then you will draw your line, 10 kilometers. So this time, you can make the line to make it a right triangle here. That is the right triangle. So this is the right triangle. We copy it only. This whole right triangle is the same as that right triangle. Okay? Then, we identify the parts. So 10 kilometers. Where is the angle? 50 degrees. And the right angle. So remember, if this is the angle, this side is the opposite. This is the hypotenuse. This is the adjacent. Okay? So, adjacent, meaning that if this is the angle, the one beside it is the adjacent. And the longest side is the hypotenuse. So the adjacent now is the y-axis because it's the vertical line, and the opposite is the x-axis. Now let's resolve it in its component. So SOHCAHTOA. So sine, opposite over hypotenuse. Opposite is the x, and the hypotenuse is 10. So it will become 10 sine 50 degrees. X is going to the east, so it is positive. Now, y is the adjacent. So adjacent is cosine. cosine adjacent over hypotenuse. Y equals negative 10 cosine 50. Why negative? Because our y is going to the south, going downwards. So this is how we resolve it. You resolve the vector into its x and y components. Now, in the next slide, I will give the same example, but another method. 10 kilometers, 50 degrees east of south. So again, the Cartesian plane. So we will find the 50 degrees east of south, meaning south going to east, 50 degrees. So 10 kilometers. This time, instead of putting a line here to make this a right triangle, I will put a line here to make this a right triangle. For me to do that, I have to get the other side angle, that is 40 degrees. Because they are complementary. Then I will write the straight line and the 90 degrees. After that, I will copy this right triangle and put it here. And I will identify its parts. So we have the 10 kilometer and the 40 degrees. So what are the parts of the right triangle? We have the hypotenuse, adjacent, and opposite. So the adjacent is the horizontal line x component. The opposite is the y component. Always remember, if this is the angle, the one far from the angle is the opposite. And the one near the angle, that is the adjacent. So let's resolve it to x and y component. We have SOHCAHTOA. Let's start with x. As you can see, the x is the adjacent. If it is adjacent, we're going to use cosine. So cosine theta equals adjacent over the hypotenuse 10. So 10 cosine 40. Positive because the x component, which is the east, is positive. 7.66. After that, we have the y component. Y is in the opposite, so we will use sine. Sine theta, y over 10, so y equals negative 10 sine 40. Negative because it is going to the south. Okay? So let's add vectors. Examples. A boy walks 3 kilometers south, then walk another 4 kilometers in the same direction, meaning south. What is the resultant displacement? So let's draw our Cartesian plane. The first vector is 3 kilometers south. From there, he walks again 4 kilometers south. What is the resultant displacement? Let's get the x and the y component of the 3 kilometers, so that is 0 and negative 3 because it's going to the south. For 4 kilometers, that's 0 and negative 4. The sum of the x component is 0 and the sum of the y component is negative 7. So meaning, the magnitude is 7 kilometers and the direction is negative. So negative 7 kilometers south. Next example. A boy walks 3 kilometers south, then walk 4 kilometers north. What is the resultant displacement? So the boy walked 3 kilometers south and then 4 kilometers north. What is the resultant displacement? So there are no x components. The y is negative 3, and the second vector is positive 4, 0, and positive 1. So this is positive 1, meaning it's going to the north, and the magnitude is 1 kilometer. 1 kilometer north. A boy walks 4 kilometers east, then walk 3 kilometers west. What is the resultant displacement? So he walks 4 kilometers east. From there, he walks 3 kilometers west. What is the displacement? 4. The x is 4 going to the east, and the y is 0. And then the second one is 3 kilometers west, negative 3 and 0. So 4 and negative 3 is 1. So what's the direction? Going to the east because it is positive. 1 kilometer east. A boy walks 4 kilometers east, then walk another 3 kilometers north. What is the displacement? So, first, the boy walks 4 kilometers east. And then from there, he walks 3 kilometers north. So what is the resultant displacement? So let's have our triangle. So the x is 4 kilometers, y is 3 kilometers. And what is the angle? And the hypotenuse. So for the first vector, the x component is 4 because it is 4 east. Then no y component, 0. For the second one, there's no x component, but there's a y component 3 kilometers north. So the total of x is 4 and the total of y is 3. Now, we need the hypotenuse. To get the hypotenuse, we need the Pythagorean theorem. A squared plus b squared equals c squared. The a squared plus b squared, that is the legs. The legs there. 4 and 3. And the c is the hypotenuse. So, c equals square root of a squared plus b squared. Just substitute. C will be 5 kilometers. How about the angle? We'll use SOHCAHTOA. This time, the hypotenuse is missing. So we're going to use this one, tangent. Opposite over adjacent. Because this time, opposite and adjacent are given. So tangent angle is, the opposite is y. Based on our drawing, the opposite is y. And the adjacent is x. So tangent theta equals 3 over 4. Then, to get the angle, we will use the arctangent. Arctangent, arctangent, 3 over 4. So the angle will be, if we use the calculator, the angle will be 37 degrees. And it is north of east. Why north of east? Because this is y. Y of x. North of east. How do we know it's north and it is east? Because 4 and 3 are both positive. So, the whole resultant is 5 kilometers, 30 degrees north of east. A school bus leaves the school and drives 10 kilometers northerly, so that's 10 kilometers north, then drives in a direction 60 degrees southeast for 5 kilometers. What is the bus displacement from the school? First vector is 10 kilometers north. Second vector, so from that point, he goes 60 degrees south of east, meaning that is east going to south, 5 kilometers. What is the displacement? So let's first get the x and the y component of the first vector, 10 kilometers north. So it is north, meaning no x component, and the y is 10 kilometers. For vector 2, we need to get the right triangle. So we already make a right triangle here, there. And we will identify the 5 kilometer as the hypotenuse. The angle 60 degrees. So since this is the horizontal, this is the x and the y. The hypotenuse, remember, the one beside the angle is the adjacent. And the one opposite is the opposite. So katoa. Now, so for the x-axis, that's the adjacent. Adjacent, meaning we're going to use ka, the cosine. Cosine adjacent over hypotenuse. X equals 5 cosine 60. And the opposite is y equals negative 5 sine 60. Then total the x component using your calculator and the y component using your calculator. Then we need to get the Pythagorean theorem. So this is our x and y component, which is the legs. 2.5 square plus 5.67 square, that will be 6 point, and square root, that will be 6.2 kilometers. And to get the angle, we're going to use tangent, opposite over adjacent. So opposite is the y and adjacent is the x. So the angle will be 66.2 degrees north of east. So the answer is 6.2 kilometers, 66 degrees north of east.